There was a time when astronomers would have labeled it a simple flyby. Today, a different word is entering the conversation: arrival. The object known as 3 divided by I Atlas isn't merely a transient visitor. It is charting a deliberate course across our solar system, a trajectory that intersects with the paths of major celestial bodies. And here is the truly startling revelation. Data from NASA's instruments suggests it could be moving at a velocity exceeding our current predictive models. This acceleration implies that its close encounters with Mars, the Sun, and Jupiter may occur sooner than we have prepared for. The fact that this object has captured the attention of agencies like the U.S. Navy underscores the scientific community's belief that its approach demands our utmost scrutiny. Why is this celestial event so critical right now? And what secrets might it unveil as it draws nearer? Initially, the astronomical community classified 3 divided by I Atlas within the well-understood category of comets, those icy remnants that periodically journey through our solar system. It possessed a characteristic glow, sported a visible tail, and appeared, at first glance, to be just another of the countless small, wandering bodies we have cataloged over the years. However, as our sophisticated instruments began to gather data, the numbers refused to align with our expectations. Instead of conforming to the known chemical signature of a typical comet, this object inverted them, compelling experts to consider a groundbreaking possibility. Could this be the first of its kind? A traveler from the vast expanse of interstellar space, carrying a chemical composition entirely foreign to our cosmic neighborhood. The object was first identified by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes in Hawaii tasked with detecting potential threats to Earth. At a remarkable distance, far beyond the orbit of Jupiter, the system flagged its movement and luminosity as anomalous. Its speed and trajectory seemed inconsistent with the familiar circular paths of objects gravitationally bound to our Sunday. Its designation as an interstellar visitor was made before it had even breached the inner solar system, a highly unusual occurrence, as most comets are not identified until they are significantly closer and brighter. But the true enigma of 3 divided by I Atlas wasn't just its path, at least not initially. It was its fundamental makeup. In conventional comets, frozen water is the dominant component, with carbon dioxide present in much smaller quantities. With 3 divided by I Atlas, this ratio was flipped on its head. Instruments detected vast plumes of carbon dioxide streaming from the object, with water being comparatively scarce. This discovery alone was sufficient to label it as a peculiar specimen. But the anomalies didn't stop there. Its coma, the luminous cloud of gas and dust surrounding it, scattered light in a way that physicists found exceedingly difficult to replicate with any known material. The particles behaved neither like ice nor like dust, and no laboratory experiment could reproduce the observed scattering pattern. Delving deeper into its elemental spectrum, scientists uncovered an even more baffling signature: the presence of nickel in the near absence of iron. In the standard model of cosmic chemistry, these 2 elements are almost invariably found together. Stars forge them in tandem, meteorites transport them as a pair, and comets entrap them side by side. To discover a significant amount of nickel without a corresponding amount of iron was akin to finding a car with an engine but no wheels. This stark contrast defied conventional scientific understanding, suggesting that the universal laws of physics may have been altered or entirely rewritten in the ancient cosmic nursery where this traveler was born. Imagine, for a moment, standing next to a vehicle on the street and noticing it has no tires and no headlights, yet it is somehow still capable of moving at highway speeds. This is the kind of cognitive dissonance that experts are facing as they point their spectrographs at 3 divided by I Atlas. Even veteran researchers, long accustomed to cosmic surprises, have proceeded with caution, aware that each new measurement seems to invalidate yet another long-held assumption. We have, of course, encountered interstellar oddities before. Oumuamua, our first confirmed interstellar visitor, was an elongated, cigar-shaped object with no discernible coma, accelerating away from the sun propelled by an unknown force. Then came Borisov, which more closely resembled a textbook comet but moved with a velocity that confirmed its origin from beyond our solar system. Both of these objects challenged our existing paradigms, yet they still exhibited some familiar characteristics. 3 divided by I Atlas distinguishes itself by shattering multiple scientific conventions simultaneously. Its potential birthplace appears to be more ancient, its chemical composition more perplexing, and its presence more disruptive than either of its predecessors. This is why scientists are speaking with such measured and deliberate language. Data collection is paramount, but this time it feels less like a routine observation of another icy rock and more like preparing for a close encounter of a kind that no one alive today will ever witness again. With every new observation, the stakes are raised. A comet's luminous face typically tells a familiar story of water, ice, and dust being warmed by the sunday. Here, the narrative is already running in reverse, and many are eagerly waiting to see if even more profound mysteries will reveal themselves as it ventures closer to our star. One could view it as a portal to an older cosmic epoch, an environment that was shaped long before our own solar system came into existence. In this sense, it is more than just a comet, at least not in the way that term has defined every other visitor that has come before it. It seems less like a random piece of celestial debris drifting through the void and more like an emissary, carrying with it materials from an environment that humanity has never directly interacted with. And if its chemistry tells a story of alien origins, its journey through our solar system promises an even stranger chapter. Because while the elements scream that it is foreign, its next maneuvers through the planetary orbits raise profound questions about whether its journey is entirely natural at all. Why does 3 divided by I Atlas appear to be navigating its way through the solar system with such precision, rather than hurtling past like a stray bullet from deep space? This is the question that has begun to preoccupy astronomers as they map its highly unusual trajectory. For an object arriving from interstellar space, one would expect a direct, linear path, a dive-in, a sharp curve around the sun, and then a departure forever. But the orbital charts for 3 divided by I Atlas depict something entirely different. Its course flattens out, aligning almost perfectly with the ecliptic plane of our solar system, the same thin disk where all the major planets reside. From there, it threads a path that brings it uncomfortably close to Mars, Earth, Venus, and even Jupiter. The ecliptic plane is a bustling cosmic highway, teeming with planets, asteroids, and other celestial bodies. The probability of an object entering from a random direction and then aligning itself so neatly with this plane is incredibly low. Typically, incoming comets intersect our solar system at extreme angles, like a needle piercing a piece of fabric. Their tilted trajectories are what we would expect. Interstellar arrivals should have no regard for the orderly arrangement of planets orbiting our Sunday 3 divided by I Atlas. However, is a different story. Its path doesn't cut across our system like a blade. It flattens out, aligning itself like a visitor who knows the precise layout of a crowded building. When its trajectory is plotted against the planetary tracks, the picture becomes even more bizarre. Its route doesn't just conform to the general plane. It appears to weave in close proximity to key planetary orbits, as if following a series of predetermined waypoints near Mars on one leg of its journey, then past Earth, then close to Venus, and then drawn back out towards Jupiter. Each of these points looks less like a random geometric coincidence and more like a scheduled stop on a grand tour. It forces us to confront an unsettling question: how much of this can truly be random? Instead of a single, fleeting encounter with the sun, its movement feels more like a sequence of brief visits, as if an interstellar tourist is taking a slow, deliberate tour of our solar system. Visualizations of its passage amplify this sense of unease. Traced against the pale blue arcs of planetary orbits, the red line of 3 divided by I atlas intersects them at multiple points. Anyone familiar with models of typical cometary paths will immediately recognize the stark difference. Random comets plunge in steeply, skim the sun, and then vanish back into the darkness. Here, the pattern is almost reminiscent of a deliberate traversal from one world to the next. Such precise tracking necessitates a change in our language. Some astronomers are no longer using the neutral term flyby to describe this event. Instead, the word arrival has begun to appear in their public statements. It is a subtle linguistic shift, but one that carries a much greater weight than a casual observer might realize. A flyby is a passive event, a passing without interaction. An arrival implies a presence, and perhaps even an intention. Even outside the scientific community, this choice of words signals a changing perspective. The fact that agencies beyond the realm of astronomy, such as the U.S. Navy, have been mentioned in connection with this object demonstrates the exceptional seriousness with which its path is being treated. For organizations trained to think in terms of tracking, positioning, and threat assessment, an object whose trajectory can be plotted like a road map naturally invites suspicion. It's not just about its composition, but about its destination and the reasons for its close passes by the worlds it encounters. A heightened state of alertness is a natural response in this context, when events stop looking chaotic and start to resemble a deliberate alignment. Does this imply that the object is under intelligent control? There is currently no evidence to support such a leap of logic. However, the very fact that such a question is even being raised speaks to how anomalous its trajectory appears when compared to everything else we are currently studying. Scientists are keenly aware that the upcoming encounters will be decisive. As it passes Mars or glows brighter in the vicinity of the sun, they may be able to gather clearer data that will help them determine whether its movement is shaped by cosmic coincidence or by some deeper, unseen dynamic. In other words, the coming months will be a test of whether the arrival label is merely a metaphor or an accurate description of reality. What is already abundantly clear is that its journey does not appear to be a careless one. Each intersection with a planetary orbit reads like a point in a larger pattern, and in this situation, perception is everything. Humanity's reaction to these rare interstellar visitors is shaped by the story their behavior tells. With 3 divided by I atlas, the narrative is no longer one of a stranger simply passing by, but of an object following a route with recognizable and significant waypoints. This fundamentally changes the way researchers are preparing, and it is shaping the public's imagination about what might happen next. And while the pattern of its trajectory alone is enough to raise a host of questions, the real drama is about to unfold in real time. Because soon, instead of just lines drawn on orbital graphs, we will witness the step-by-step encounters as it sweeps by Mars, dives near the sun, and then moves outward toward Jupiter. Imagine having the ability to watch almost in real time as an interstellar relic traverses the various stages of our solar system. First, it will brush past the orbit of Mars. Then it will make a perilous plunge close to the Sunday. After disappearing from our view for several weeks, it will re-emerge to continue its journey outward, swinging by the gas giant Jupiter. Each of these steps presents a unique opportunity for learning. like chapters in a story that no one on Earth has ever had the chance to read before. This is not just another comet passing by. It is a narrow, fleeting window of time where our instruments must be poised and ready, because once it is gone, it will be gone forever. The key dates are already marked on our calendars. In October of 2025, the object will sweep near Mars, which could provide us with our first clear glimpse of its hidden solid core. Just a few weeks later, on October 29th, it will reach its closest point to the Sun, the moment that astronomers are anticipating with the most excitement, as the intense solar radiation may reveal secrets that ordinary observation cannot. By December, it should emerge once again, this time stripped of its outer layers, altered, or perhaps even broken apart into visible fragments. And then its forward march will continue, this time toward Jupiter, where in March of 2026 it could brush past the domain of the gas giant, giving a major space mission one final chance to get a close look before it sails away into the eternal darkness. The tension surrounding these dates is heightened by how brief and unforgiving this window of opportunity truly is. The Mars encounter in late October 2025 will offer only a fleeting chance, less than a week, for our cameras to capture the object as it moves away. If we miss that timing, the data will be lost forever. Perihelion, its closest approach to the Sun, is our single best opportunity to strip away the veil of gas and dust that surrounds it. But here too, the timing is critical. The coma may expand, the nucleus may fragment, or it may become too bright for some of our instruments and too faint for others as it recedes from the sunday. By the end of March 2026, our final chance will have passed, and no instrument on Earth will be able to bring it back into view. 3 divided by I-Atlas might be more than just a comet racing through our solar system. It could be the carrier of the oldest story ever told in space. The Otatai-Oxford model suggests it may be approximately 7 billion years old, older than our solar system itself. This incredible age could explain why its chemistry feels so alien to us, containing materials from a time before the Earth was even formed. If it is indeed moving faster than our predictions, this countdown will shorten, forcing us to make discoveries sooner than scientists had ever thought possible. And so, the ultimate question becomes, is this merely an ancient relic passing by our cosmic neighborhood, or is this the first moment that human observers are witnessing our solar system playing host to a much wider galactic conversation?